Hello, good morning, all. Today I'm associated with CellStrat for last 2.5 years as a AI researcher. Today we will be looking at the latest SOTA model Whisper. Let's get started. So OpenAI is a robust speech recognition via large-scale weak supervision. We will see what is that in a bit. So let's get our fundamentals clear first of all. So,
Niraj, are you sharing your screen? We can't see.
oh, I'm sorry. Yeah, mm, right.
Yes, yes.
So, yeah, we will look at robust speech recognition via large-scale weak supervision today. So, let's get fundamentals clear first of all. So, we leave our lips and tongue, and we exit means we create the audio waves through our vocal tract. Now this vocal tract, when we create, it is recorded as amplitude versus time. So this is the normal raw audio waveform that we see. So as we speak, the amplitude of the sound waves goes up and down, and we record the audio waveforms, and we can convert it to the Mel frequency spectrogram. This is how our ears can understand what we are speaking. It internally converts it to frequency and understands the words that we are speaking. So, what is weak supervision? It is a part of machine learning where unorganized or imprecise data are used to provide indications to label a large amount of unsupervised data so that this large amount can be used for machine learning or supervised learning. Right. So basically, in a modern world, modern all the deep learning models require very large amount of data to so that they can be accurate. But this data is not always available. For example, uh, speech data in Indian language, Hindi, Tamil, Telugu, Marathi, Bengali. So this amount of this data is not easily available, or if and it will require huge amount of efforts to get this data. So in such cases, we use this weak supervision. So how this is achieved? So uh, we can create weekly supervised learning. So let's go to the what are the unstructured data. So we can get a large annotated data sets or semi-supervised data sets. So in case of weekly supervised, we get it from the non-experts, the annotations. Then we identify the patterns. Then we can do the batch annotations. Using noisy predictions, we can from the pre-trained models we can also use that. So this gives us the supervised learning large data sets. So this can be achieved. So we can get a large data set using this weekly supervised method. So this is less expensive and we can get a decent amount of data. So how to get more label training data? This traditionally we get large training data using the supervision, and weekly supervised data we get low quality cheaper data, and we organize it appropriately so that we get large amount of data for our model training. So let's directly dive into our whisper model. It is basically a classic encoder decoder model with cross attention. So input to the model is the log mail spectrogram. We convert the input audio into the spectrogram and give the input. So conv 1D is used to identify the positional encoding of the data, and then we have a number of encoder blocks that will encode the data and create our uh, vector for decoding. So on the decoding side, we have the multitask token. So there are multiple tasks assigned to this particular model. First is translation. First is recognition of language, then transcribe, and then translation. So here, when we get the uh, our vector for translation, encoded vector, we it identifies the positional encoding, and then it goes to the decoder box, and we get the final output over here. So far, so good. So there are multiple tasks assigned to the Whisper model. So in this special case, first of all, uh, start of transcripts. Firstly, it identifies the language. Uh, First is voice activity detection, and after voice activity detection, it identifies the language, which language is the input. So depending on the task, if it is a English language, it will transcribe. So beginning of time. So and it will give the output beginning of the time, text token, and end of time. So this gives time aligned transcriptions. So we get appropriate time for each output that is being transcribed. For for translates, it doesn't give the timestamp. So if it is a non-English language, it will translate to the English language and give the text output. So these are the so Whisper is basically an architecture end-to-end end-to-end approach implemented as a encoder decoder transformer. Input audio is split into 30 seconds chunk and converted to mail spectrogram and then passed to encoder. A decoder is trained to predict the corresponding text caption intermixed with special tokens that direct the single model to perform tasks such as language identification, phrase level timestamp, multilingual speech transcription, and to English translation. So, since it is multi-language, multitask model, it has following. It gives identifies which language is the input, and also it gives the phrase level timestamp for the English language. So these are the tokens. Normally, in case of our simple machine translation or speech recognition, we just use the sorry, start and end. So since we are having the multitask, we are adding special extra tokens in our Whisper model. So these are start of transcript, translate, transcribe, start of language model, start of previous, no speech, no timestamp. So in case it also identifies where there is no speech or no timestamp required, means whenever there is a silent part in the audio input. So the model is trained on the 680 hours of audio data, that is collected from the internet. Mainly, it is connected through YouTube or where there are various other audio channels available. And then it's no normally this is uh, not very accurate. The data that we get from the scraping the internet is not very accurate. So they have done the weak supervision part, and in the weak supervision part, it will automatically try to make this data more accurate by internally learning and internally uh, making it a labeled data. So 65% of it is the English language, and roughly 18% non-English audio and English transcripts. The 17% audio represents the non-English transcripts, right? So again, we will go in a little deeper into the architecture of this whisper model. So 600K hours of data. So English translation, transcription, if you are doing, then it will convert, it will identify the language, and there are multiple layers of in the output, and it will give the appropriate output. So how it works is start of transcript. It identifies the language tag after detecting the voice activity. Then for English, it will do the transcript, begin of time, and each timestamp, each phrase of the English transcription is time stamped. So it will give the output appropriately. So it performs multitask, English transcription, any to English speech translation. So since it has uh, non-English audio, and the output of that non-English audio is in English transcript. So it does the automatic translation of that also. That particular data is provided at the training time itself. So when we give in Spanish, it will convert directly to the English, and also it has non-English transcriptions. We give the input and output will be in the that particular language, right? So these are the multitasks that this single model performs. So English translation, but the English translation has no timestamps. So that part we have to take care. So how is the model then and training done? So it is trained on the various speech processing tasks, multilingual recognition, speech translation, spoken language identification, and voice activity detection. All the tasks are jointly represented as sequence tokens that we have seen earlier, and to be predicted by the decoder, allowing a single model to replace many different stages of traditional speech processing pipeline. The multitask training format uses a set of special tokens that serves as a task specifier or classification target. So this can be particularly useful. Suppose if there is a means nowadays we see a lot of audios in the prime means a lot of Netflix videos or Amazon Prime videos that use the direct transcription in direct translation into the local language. We can set the um, language for the translation. Sorry, language for the text that appears on the video, and we can so this earlier we had to use multiple model. First we have to do the speech recognition and then the translation, but these tasks are combined into the single model for the whisper AI. So what are the languages covered? So Spanish, Italian, English, Portuguese. This is the list of languages. It has so many languages, including many of the Indian languages for translation, and it gives the word error ratio for Spanish, Italian, English, Portuguese. Since the data is large, the word error rate is very less, and for Sindhi, Sona, for the other languages, the word error rate is very high. This has been tested on the Lewis dataset. So when we compare this word error rate for the English language specifically, so it outperforms the Wave to Wake 2.0. So and it is outperforms the uh, human is almost very near to the human level speech detection. So when we see supervised library speech models, these are the other models. Here is the whisper where word rate error rate is very low, and zero shot human Alex. Here is in the orange it shows the word error rate of human, and many of the models of whisper perform better than the human uh, human speech recognition. So let's see wave to wake performs gives word error rate of 2.7. Whisper also gives a rate of 2.7 on the library speech data set. When we see RT, or there are various different data sets. So in each of the cases, Whisper is outperforming the Wave to Wake 2.0, right? So multilingual speech recognition, how it performs. So there are different multilingual speech recognition models like MSLAM and all. MSLAM, of course, performs quite better. And this MLS dataset and Vox Populi, these datasets are multilingual datasets available. So MSLAM performs better than the Whisper in in the Vox Populi dataset, whereas Zero Shot Whisper performs better on the MLS dataset. So this model is almost state of the art when it comes to the speech recognition and translation, multilingual speech recognition. So how it performs on the translation. So as this is the blue score. So blue score is used for the translation. So on various languages, it is given how it performs. It depends again on the input data size. The more data we give for the training, the better will be the performance. So long form transcriptions. So it has compared the long form transcription with various other companies on the long form transcription is basically the transcription of long text. Suppose we have a paragraph of say 100 words or 200 words. This can be easily uh, transcribed by the whisper, and it will give us the output. So there are various comparisons between various companies. This is the NVIDIA speech to text translation, and Whisper definitely performs on the word error rate. So, for example, on the Coral dataset, the error rate of NVIDIA is lot higher, and Whisper error rate is very low. So, this is the overall comparison with the various commercial open source automatic speech translation systems. So how it performs compared to the professional transcribers. So it is almost comparable to the professional transformers. So word error rate of computer assisted professional transcriber is 7.61 and whisper is 8.76. So it's very comparable with the professional transcribers. So they have compared with various transcribers A, B, C, D, and they are also uh, this is the this is whisper model on various data set A, B, C, D, and same on the same done by the professional transcriber. So it is very comparable to the professional transcriber, and we can, if in the future, probably many other future models that will come that will outperform the professional transcriber. Just the so there will be no need for paying to the transcribers. We can just use this model. So what are the size of the models? So and how it is the how the performance scales with the size of the models. So English speech recognition size of the model, as the model parameters increase, the word rate error rate decreases. On multilingual recognition, again the word rate error rate decreases. So blue score, the higher the blue score, better it is. So when the number of parameters increases, the blue score increases and the performance translation is better. Again, the accuracy on language identification on the fluid score. So number of model parameter increases, the accuracy also increases for language identification. So this is the dataset size that is being used for the training. So earlier this 3405 is the dataset size, and with this we get this word error rate of 30, and with 681,070 dataset size, the error rate is 9.9. So as you can see, the dataset size increases, and thus the model performance is lot better with the larger data size. Oh. So in short, Whisper takes the advantage of weak supervision, supervised training, and it uses 680 hours of multilingual, multitask supervised data, and data is scrapped from the internet. And we can see that weak supervision can be used on the widely available data to get the SOTA performance. So, any questions so far?
So friends, feel free to bring up comments or questions. It's a complex algorithm.
Niraj, good morning. This is Anand this side.
Hi.
Um, Thanks for the wonderful talk. Um, so when we call this Whisper with now weak supervision model,
Hmm.
how much effort one need to take in case if you wanted to take it to the production? Kind of even I think a 10% word error rate should be fine, right? So 90% we get an accuracy kind of stuff.
Yeah.
So where the accuracy doesn't matter, but I need to get the context of the text. So this should be fine. So what kind of efforts needed to take this kind of model into the production?
So currently this model is almost production ready. They have open source this model for as far as English language is concerned. Only the constraint here is that it requires GPU for doing the translation or doing its operation, because since we saw the size of the models can be very large. So let me just show this. So size of the models is for tiny it is 39 MB. For large model, it is almost 1.5 gigabytes of model. So the model size is very large, so it requires a GPU. So for English uh, English transcription is concerned, it's almost production ready, and we can almost use it as it is.
Okay. And in case if we need to use it for a domain specific areas, for example, I wanted to use it for only on healthcare or in law firm or something. What do you think, like how much of data we need to feed to get it specialized on that domain?
Yeah, so as far as data size is concerned, I think we have seen in this PPT. So data size, so data size with a few thousand hours of data, we can get a pretty good hour rate. So as we increase the data size, it will keep on increasing. So now, since we already have the pre-trained models available, so we can use the transfer learning and retrain the model, and mostly it will require GPU. So probably 1 week, 2 week, or maximum 1 month of efforts may be required, because since it's a very large model, you need to train on the GPUs, and that may take quite a lot of efforts for custom data sets. So we
Okay.
can use transfer learning, and we can retrain this model for any kind of custom data sets.
Okay. Okay. Thank you, Niraj.
Right? Any more questions?
Okay, Niraj, you have a demo?
Yeah, we have a small demo. Right now, I will just play this. I just created a very small file. Can you hear it? Let me remove the headphone. Namaskar. So we will just use this simple file. So this will give the yeah. So as you can see, I'm running on my CPU right now. Can you read it, or should I increase this size?
Yeah, a bit more in. Yeah, now it's okay.
So it will take about few minutes, 1 or 2 minutes, because as you can see, it's in Hindi language, so it has to go through all the process, detection of words, detection of voice, then detection of words. I have specified the languages as Hindi, so the output will come in Hindi. But we can obviously use many of the languages um, that are available. So since it is running on the CPU, it is taking quite a lot of time. And I have tried to see, there are multiple sizes of models available. Uh, so currently I am using medium, because for the Indian languages, the tiny and base model, they don't give very good accuracy. So that's why I'm using a medium model. So medium model size itself is large, almost 769 MB, and see, we'll get the output here. So yeah, a little bit of uh, instead of m, it detected w. So there is a little bit of error over there, but rest of the text audio is detected properly. And Yeah, there is a couple of one more thing I want to. So let's go through the paper. So most of the things are there that are already that I have already explained. Now you can go through the paper and it explains in more. You can see in more detail. So now they have compared this model. So various models have been compared to wave to wake and all that, and various data sets have been used. So let me now how they did the text standardization that also they have explained. Remove any phrase between matches brackets. So they have now removed all the brackets and parentheses. Remove any words. Remove word space, apostrophes, and all that. Remove commas between digits. Remove previous. So these are the pre-processing they have done. Convert British spelling to English spellings. So different language specific pre-processing is same. Removing the brackets, replace marker symbols with Unicode category. So this is the pre-processing they have done for all, and here they have explained, and they have just at the output they have used various types of uh, means how do you say, decoding techniques. So in Greek greedy decoding, they have means word error rate is different, and they have compared it with the wave to wake models. Then beam search also they have used. So they have tried the different types of techniques available for decoding, and given the what is the word error rate for each and every language in more detail. So multilingual libre speech, how it performs, they have explained. Vox populi, fluids. Yeah. So if you want more in-depth information, you can use this. So training data statistics, 65% English, 18% translation, and 17% multilingual speech recognition. Hyperparameters, they have explained here. Adam W optimizer, weight init, Gaussian fair, linear decay. Right.
So just to list the business applications, Niraj, one is speech recognition.
Yeah.
What else can we accomplish with Whisper?
Yeah, we can be not dubbing. Mm, I forgot what you call the text comes below in the video.
Caption. Image captioning. Okay.
Sorry. Yeah. So caption we can directly, if you want, if some movies in Hindi or Marathi or Tamil, so we can it can directly give the caption in English language. We don't need multiple languages, and it can detect. So if you want to do the multiple language translation, so at the output of this we can, suppose we want Tamil to Hindi translation, we can directly assign uh, uh, English to Hindi translation at the output of at the Tamil output, and we can directly get Tamil to Hindi translation. So there are a lot of all the applications related to the translation and speech recognition can be used here.
For translation, you will have to append Google Translate or something to the end of it, right?
Yeah, for non-English translation, yes.
Okay. So once you transcribe the speech to text, then you can use it for translation or few other applications maybe. Of course,
Yes.
video captioning of OTT television, so cricket commentary and so on.
Yeah,
Uh,
many
oh,
applications are there.
yeah. So this doesn't have any interplay with the new Chat GPT, does it?
No, I don't think so.
That is a chat bot, right? That's different, right? So that's just an intelligent chatbot.
Yeah, that is more about dialogues.
Right, like Rasa. So that's different. Okay.
Yeah.
Okay, fine. Any other questions, audience? So did you try other languages apart from Hindi?
Yeah, I tried Kannada, Tamil, Telugu, and German. So it worked quite fine. I think there are some texts how we can convert transcript to Indian local languages whose corpus is not available. Yeah, that will be a difficult task. So what we have to, at least we should have some data available. If not professional level data, but still we need to have some data available for doing. Otherwise, it will be an unsupervised task. So for weekly supervised, even if we have some uh, data that is translated or transcribed, then we can use this weekly supervised method to make it more accurate, right? So even it doesn't matter if the data is less or more, but at least we need some data for supervised learning.
Hmm. So languages which are not available in Google Translate or Amazon Translate will not be able to be supported.
Yeah.
Okay. Any other questions, audience? Uh,
I'm sorry, the CPU may not be sufficient for this uh, whisper model. It may be sufficient probably for the base model. Um, so if you can see this tiny model and base model, these are this gives quite a good performance on English language, right? So you can try this tiny model or base model, and the output you can get it quite quickly for the English language only. But if you want multilingual recognition, then I think you will need GPU and higher end model to do that, because base model accuracy is not that good.
so Professor Nandini, we are actually about to launch an API on GPU for this Whisper model. So we are using SageMaker though, not CellStrat Hub in backend. So we are about to publish an API where Whisper can be called through an API interface. Uh, and it will be GPU driven on SageMaker. So that is about to come on within the CellStrat product. So that you will be able to use for the project related to the specially able person's voice. So we'll have to see if the voice of the especially able person's voice, it is able to do justice to, right? That we'll have to test.
Yeah, otherwise you can always retrain. I mean, the transfer learning can be used to retrain the model. It will require some efforts and some GPU units, but yeah,
So we'll need data for that kind of voice to do transfer learning.
right.
Okay. Any other questions, audience? So Neeraj, when you said you tested other languages, so how did you verify they are accurately transcribed, or you just compared visually?
Well, there is a Google Translate, so whatever output I got, so I put it in the Google Translate and try to test.
Okay. So you translated it further because you would not know all those languages, I'm guessing. Okay. All right. Sounds good.
Yeah, so that's what I did.
You tested it with Translate. Okay. Any other comments, audience? Okay. So Niraj, is that about it?
Yeah.
Okay. Thank you, audience, for joining. Thanks, Niraj, for an interesting presentation on a cutting edge algo. So we'll look to future webinars from you.
Okay. Thank you very much for joining.